Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, and good night, everybody. Yeah, my name is Abidatur Rashidah, your online physics mate. Even though we couldn't say that the pandemic is already getting better, but yeah, we still have to deal with it in this new normal era. And nowadays, when you entering a certain building, the security guard will always check your temperature first, right? Whether it's manually with thermogun or automatically with thermal image sensor. But my question is, what exactly temperatures means? Yeah, in everyday life, we often say that temperature is a measure of how hot or cold something is. But if we see them further, temperature is much more than this. Alright, before everything, let's watch a video from my favorite physics channel, Veritasium. In this video, Veritasium wants to tell us that there's still a lot of misconception about temperature. At first, he asked people to tell which one has the higher temperature. Is it book or a metal hard drive? Or the temperature is just the same? And just like what we saw, most of them answered that the book feels warmer than the hard drive. So it means that the book has a higher temperature. But when in the end he measured both of the book and the hard drive's temperature, it shows us the same number.
Okay.
What do you see?
19.0.
Okay. And measure the temperature of that.
19.0.
The second experiment is, he showed the people two blocks. One of them is made of aluminum and the other is plastic. And then he asked them if he put an ice cube on those plates, which ice cube is going to melt faster. And yeah, the people said that the ice cube will stay solid on the aluminum block because it is colder. But in fact, the ice cube melts faster on the aluminum block. And all of them and us be like,
what? How is that possible?
Well, mate, life is all about balance. Whether it's balance bank account, balance diet, or balance between school, game, and Korean drama. Alright, in science, the word for balance is equilibrium. If two objects with different temperature are placed into thermal contact, just like when we put ice cube into our hot coffee, their thermal energy will transfer from one to the other. And in the end, the two objects will eventually reach the same temperature. Experiments indicate that if two systems are in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. This postulate is called the zeroth law of thermodynamics. Well, let's go back to our problem. So, based on that zeroth law of thermodynamics, whether it is metal disk drive or book will eventually reach the same temperature with your palm when you put them into a contact.
So, that's also the reason why the ice cube on the aluminum block melts faster than the one on the plastic block. You know, aluminum are conductor and plastic are insulator. Thus, the aluminum could transfer its thermal energy to the ice cube easier than the plastic.
The next fact that I want to tell you is, when the temperature of a certain thing is increasing, the only thing that changes is not as simple as, wow, it's getting hotter and hotter when I touch it. But basically, many properties of matter will change with temperature. Number 1, the color. In high temperature, solids such as iron will glow orange or white. You may have noticed that the heating element of an electric stove glows with the red color when hot. Even the surface temperatures of the sun and other stars can be measured by the predominant color of light they emit. Number 2, the electrical resistance. Based on macroscopic or a large scale, we distinguish three common phases of matter: solid, liquid, and gas. But if we take this further, for example, in the phase change of water, from the atomic or the microscopic point of view, we could see that below 0 degrees Celsius or 273 Kelvin, where water is in a solid state, the attractive force are strong enough that the atom or molecules move only slightly. As you can see, they only oscillate relatively in fixed position. And as we increase the temperature, it's changed into a liquid. At this point, the atomic molecules are moving more rapidly, because the forces between them are weaker, so that they are freely passed around one another. Above 100 degrees Celsius or 373 Kelvin, the liquid water changes into a gas. And from this beautiful animation, we can see that the force between them are so weak, and they don't even stay close together. Moreover, their speed is so high. From those animations, we can conclude that when the high temperature is occur, the atomic of a conductor will vibrate more, which in turn make it more difficult for the electron to flow. So, the electrical resistance is increasing. Number 3, the size. Most of material expand when the temperature is increased, just like a wire getting longer when the weather is hot and contract when the weather is cold. Alright, experiment indicates that we can calculate the linear expansion with this equation, with delta T is the change of temperature, LO is the original length of the object, and alpha is the coefficient of linear expansion. And when we are going to calculate the volume expansion, we can use this equation, with beta is the coefficient of volume expansion. And the value of beta is 3 times alpha. Because, you know, measuring or calculating the volume expansion is just like calculating linear expansion, but in 3 dimensions. Alright, thank you for watching this video. I hope it could help you to understand more about temperature and also clear all your misconceptions about it. Right now, please click the red button to subscribe, click share, and thumbs up to support this channel. Syukran ala ihtimamikum. Hasbunallah wa ni'mal wakil. Assalamualaikum warahmatullahi wabarakatuh.